The next two examples will give you what's called a Bernoulli first order ordinary differential equation. Bernoulli first order differential equation looks almost linear in form. Notice that this dy dx plus p of x y is classic for linear. But instead of having just a function of x on the right side of the equation, you have that function of x multiplied by y raised to some power. Now, if this power n is 0, then the equation is linear in form. And if y is 1, it's also linear because you'll be able to combine these p and q together to form a single term. If you have a Bernoulli first order ODE, then making the substitution u equals y to the 1 minus n will change it to an equation that's separable. So let's look at number 6. Here, notice that the equation is Bernoulli. Excuse me. This equation is Bernoulli. On the right side, the function of x is just 1. And then here, y to the second power, the power of y tells you that n is 2. This is Bernoulli, and we can make the substitution u equals y to the 1 minus 2 power, and it will change this into a linear ODE. When u is equal to y to the 1 minus 2 power, that gives you y to the negative first power. And then if you solve for y by raising both sides to the negative first power, you'll get y is equal to u to the negative first. Here when I substitute in, I want to substitute in for y and for dy dx. So if y is u to the negative first, then dy dx is equal to negative 1 u to the negative second du dx. So let me make my substitutions. Dy dx is negative 1 u to the negative second du dx minus 5y, y is u to the negative first, equals y squared, that's going to be u to the negative first squared. This u to the negative first squared can be simplified to give you u to the negative second. So I have negative u to the negative second du dx minus 5u to the negative first equals u to the negative second. And this should make the equation linear. To write this in linear form, I'm going to want to get rid of this coefficient of du dx by multiplying by negative u squared. That way the negatives cancel out, and u squared times u to the negative second will give you u to the 0. It'll cancel out those u's. That'll give me du dx. It's going to change this minus 5 to a plus 5. And u squared times u to the negative first gives you u. On the right side of the equation, negative u squared times u to the negative second gives you a negative 1. This is in linear form. Because this is in linear form, we want to introduce an integrating factor. The integrating factor is in the form e raised to the integral of the coefficient of the u term, 5, with respect to x, or e to the 5x. So multiplying each term by e to the 5x, we get e to the 5x du dx plus 5u e to the 5x is equal to e to the, there's a negative there, negative e to the 5x. And this left side of the equation can be written as a single derivative, d dx of e to the 5x times u. To get rid of this derivative, you want to integrate both sides with respect to x. And on the left side of the equation, you get e to the 5x times u. On the right side of the equation, when you integrate an exponential with a linear exponent, you get back that same exponential, but you need to divide by the coefficient of x. Divide by 5. And then add your constant of integration. From here, we can solve for u by multiplying through by e to the negative 5x. I'll bring that up here. That way this e to the negative 5x and e to the 5x cancel. They give you u. On the right side, the e to the 5x and the e to the negative 5x cancels. You get negative 1/5 plus c e to the negative 5x. Okay, and then we need to substitute back in for u. U is equal to y to the negative first. And because I have a negative first as the exponent, meaning the reciprocal, I'm going to want to take the reciprocal of this right side also. So I'm going to write both of these numbers using a denominator of 5 and then combine this into a single fraction. So I get negative 1 plus 5c e to the negative 5x all over 5. And then applying the reciprocal to both sides, raising both sides of the equation to the negative first power, I can solve for y. And on this fraction, I'll just flip it. So I get 5 over negative 1 plus 5 c e to the negative 5x. You may not want to see a negative exponent in the denominator. If so, you might want to take this fraction and multiply by e to the 5x over itself, so that you get an equivalent answer that looks like 5 e to the 5x. In the denominator, distribute through by that e to the 5x to get negative e to the 5x plus 5, plus 5c. And there's your answer.